When you see something like this, okay, this actually does mean something. What do you think the 1 means? The first row, right? So what type of quantum number is that?
That's
1.
What's the name of it?
Angular.
Not angular.
Principal
Quantum number, all right? So the 1 stands for the principal quantum number, the energy level, okay, the periodic row that it can be found in. What does the S tell you?
Sulfur.
No, that tells you
Magnetics.
the level.
Shape. Okay, the shape. And the shape, that quantum number is called, I know it's got a, oh my gosh, where is it at? Where are you at? There's supposed to be another box that's going to pop up. It won't appear. What is wrong with you? Thank you. The angular momentum. Okay, your DQ question for today. And then this 2 tells you the number of electrons that are in that orbital, and S can only hold 2. Okay? Okay, so I'm going to move on here. I'm going to go through a scenario. Elvis Perkins, a rather shy fellow, is getting on this school bus, or this bus. We'll just say bus. At the right. Which seat do you think he will probably sit in?
The back left corner.
The back left corner, because
He's
it's
shy.
open.
There's nobody there.
Okay? Excellent. Okay, what about this question? Marta Warren gets on the bus after Elvis. She is tired after a long day at work. Where do you think she's going to sit?
The front right one. The front right one.
Front left.
I go in the back
Nah,
and take a
the
nap.
front right because that's the closest.
Yeah, just like
You can
fill
pop
it
a
with
spot.
that.
I would go to the open one so then I could lay down and take a nap.
No, you dork. Oh my god, you should go on after Elvis so that seat is taken.
Why the hell would Elvis Presley ride a public bus?
It's not Elvis Presley.
I'm just going to tell you, I am recording this lecture right now, and that is gold. I hope that got caught on there.
Yeah, Curtis is an idiot.
All right, in your experience, do strangers getting on a bus like to sit with other people if there's an empty seat available? Yeah, okay. Believe it or not, electrons are the same way. Electrons will fill orbitals that have open spaces, and then they will go back, and then they'll double up. Okay. All right, so here is the first rule for electron configuration, which is the arrangement of electrons in an atom, the Aufbau principle. Basically, electrons fill the lowest energy orbital that it's like supposed to be in, and there's an order to that arrangement. It always starts with 1s, okay? And then the next order is going to be 2s. Then it goes to 2p. Then it drops down to
You want us to write this out?
okay, I would, because then you know the order.
Can you
Or
do
if you
your
want me
little
to write it all out, just know it's going to take up, like, I don't know how to explain it, but the order goes 1s, 2s, 2p, 3s, 3p to 4s. God, I can't write.
Why doesn't it go to 8F or 8S?
So that's why the arrows are there. So you start with 1s, 2s, 2p, 3s, 3p, 4s. So this is like a way to help you figure out the order. You list all the s's. There are 7 s's, right? 7 of them. Then you look at your p's. Well, there's no 1p, so you list all the p's. If you look at your d's, there's no 2d or a 1d. There's no 7d either. And then there's only 2 f's, which are the lanthanides and the actinides. So then you draw this arrow to show the order. So after 3d, it would be 4s. 3d, 4p, 5s, 4d.
Oh shoot. I think I did wrong. I haven't gone through it.
Okay, so yeah, that's like the order of all the numbers and all the letters. So you just list them all and then just follow the arrow. 1s, and it goes to 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and so on and so forth. As you go down, you're increasing energy because the electrons are getting into higher energy shells. But now, the majority of your electron configurations, I mean, I'm like super nice, and you don't use all of them. Okay, I try to keep it kind of like in this area. My chemistry teacher, he made us do all of the elements on the periodic table.
Yeah.
So that was fun. But
That'd take me about 18. What was his name?
Mr. Larson, and he still teaches there.
Oh, it's Brad.
Honestly, I don't know what his first name is.
I think it is.
Huh?
Michael Larson. I think so. Bands afterwards.
No, not that guy.
Oh, not that guy.
Not that guy.
Oh, yeah. No, he is.
Okay, second rule or principle is called the Pauli exclusion principle. No two electrons in the same atom can have the same set of the 4 quantum numbers. So like carbon has a unique electron configuration, that's carbon. Oxygen has a unique configuration, that's carbon. And then the Hund's rule, orbitals of equal energy are each occupied by 1 electron before the orbital is occupied by a second, and they have to have, when you fill it in, they have to have the same spin state, and then when you go back, it's got to be opposite. So you're probably wondering what the hell does that mean. So let me do an example, and I have to sit down and do it because I have to show it on the video here. So I'm going to get a pen. Okay, take a look at oxygen. How many electrons does oxygen have? Look at the periodic table. How many electrons does oxygen have? 8.
8.
Okay? So if I wanted to show the orbital notation for oxygen, I start with 1s, right? Because that's the first. And S, does anyone remember how many dashes are in S? 1. So I'm going to draw a dash above. And then I'm going to fill it. And I'm going to use arrows. I've had people do like upright hearts, upside down hearts, and smiley faces and frowny faces. And I was like, oh my gosh. So I'm just going to do arrows, okay? When I do my arrows, because you're going to be drawing a lot of arrows for the next couple of days, I just put, like, this is my up arrow. And this is my down arrow. So you notice I fill one, and then I fill the other, okay? And it's opposite spins. One spin in this way, one spin in the opposite direction. So I have 2 here, all right? So then after this is filled. So then I move on to the next subshell. So after 1s, it's 2s. How many dashes does an s have? 1. So I draw up 2s, I put a dash, and I fill it. Now I started with up. So that means the next one also has to be up. If you do down and then up, I will mark it wrong, because you have violated Hund's rule. All right, so I have 4 electrons. I still need 8 more, right? Okay, so after 2s, this is filled. What's next? 2p. How many dashes does a p orbital have? 3. 1, 2, 3. Okay, so now I'm going to fill them. Okay, so I have 2, 4. This is electron number 5. Notice I'm going up. Now I'm going to fill all of my dashes first, like Elvis Perkins. Okay, remember the Elvis Perkins? You fill every bus seat first before you go back. And yeah. So I'm going to put an electron there. So there's 5, here's 6, 7. Now I filled all the bus seats, and then I'm going to go back. 8.
Oh, nice.
What?
So you fill each bus seat first and then you go back. See what the S is, there's only one bus seat, so fill it and then move on.
Oh, because each thing has 4.
Okay. Can I move on? Okay. So you'll notice the periodic table, okay, is arranged by blocks. This is our S block, our D block, our P block, and then our F block. And the thing I want to point out is here's oxygen, okay? And it's in the 2P block, and in my example, I ended at 2P4, right? And when I count across, 1, 2, 3, 4, you're right.
Oh, snap.
They thought of everything was periodic.
Oh, they sure did. Okay. So you notice here was oxygen. We ended at 2P4. Okay. Okay, now, there's a couple different ways to show electron configurations. What I just showed you is the orbital notation, which is your dashes. Okay.
No.
Dashes and arrows. I don't know if you can, I don't know what you have. Arrows. Oh God, this is so bad. Dashes and arrows. Oh wait, what? Nope, I take that back. I got them all mixed up. Go me. Don't write that. My bad, my bad. This is, no, it is dashes and arrows. What am I doing? It is dashes and arrows. Lucky for you, I get the undo button, but you guys don't get that pleasure. Dashes and arrows. It is dashes. I saw the next one and I saw dashes and arrows and I freaked. Oh, I freaked out too early. Okay. So the next one is the electron configuration, which means you don't use dashes and arrows. You use superscripts, okay, to show it. So if I wanted to do oxygen, I would go 1s2, 2p4. No, 1s2, 2s2, 2p4. So we'll do some examples on the next slide here with that. And then the noble gas notation is a shortcut where you put the noble gas in brackets and then just resume the notation. Okay, so here we got some examples. Is this what it says in your notes? Argon, sulfur, and SC? Yeah? Okay, so argon. How many electrons does argon have? All right, so we have to get to 18.
18.
Okay, so we're going to do the orbital, and orbital is with the dashes and the arrows. Okay, so we always start with 1s.
Yep.
And we fill it. After 1s, it's 2s. After 2s, it's,
What do you, is that a 1L? Or is that a 1B?
those are my, what are you talking about? These are
Those
arrows.
are arrows. Were you not here when she was just talking about her
These are my
smiley
arrows.
faces and R and
Why would I want to waste time and make it look like that? It's going to take me forever. So I'm going to do a shortened version of my arrow, and if you don't like it, you figure it out.
Zach's definitely gonna be the guy to do hearts upside down.
You missed.
Hearts.
He's going to do hearts, or
Yeah, he is.
and he's going to do middle fingers for me.
Yeah.
Okay. So we have 1s, 2s, after 2s it's 2p with our 3 dashes. All right, so I'm just going to stop and make sure I didn't pass 18. 2, 4, 6, 8, 10. All right, we got 8 more. So after 2s, or sorry, after 2p, it's 3s with 1 dash. I'm just going in order. S's have 1 dash, P's have 3. So now I'm at 12. What happens after 3s? 3p. All right, so I'm at 12. 2, 4, 6, 8, 10, 12. So here's 13, 14, 15, 16, 17, 18. Orbital notation. Okay, so I have 18 arrows. The arrows stand for my electrons. They all have opposite spins, or where we're supposed to be. If you notice on the periodic table, 3p, there's argon. 1, 2, 3, 4, 5, 6. We're good. Okay, the electron configuration is you write it's the superscript. So I'd write out 1s, and how many electrons were in that s? 2. So I go 1s2, and then I go 2s2, and then how many did I have in 2p? 6. And then after 2p6, it was 3s2. And then we ended with 3p6.
They're all connected.
Oh, yeah.
It's like one long thing.
Yep, so however you want to view it. But this is like your exponents. Okay? Okay, the noble gas is a shortcut. So to do, you can't just write argon in brackets. You have to go to the noble gas before it. Okay, so we look at the periodic table. The noble gas before argon is neon. So I'm going to put the neon in brackets. And when I do this, I'm going to change my pen color here. Neon ends at 2p6. I've literally eliminated this, and then I'm going to resume notation. That's what neon is. Neon in brackets is all of this. So then I just resume notation, and it's 3s2, 3p6. Does everyone understand how the noble gas configuration is an abbreviation?
So how did neon end at, how were you able to, how'd you know to cross those?
Yeah.
I can look at the periodic table and say, oh, neon's in the 2p. So I can basically, yeah, you don't write anything
After 2B.
After
before 2p.
Before, yes.
before
yes.
2B.
Yep, and then you just resume. So, or you could say, you can find neon in brackets, and then just go down. Oh, I start with 3s. 3s2,
Okay.
3p6.
Okay.
However you want to do it. It does, because you're like, okay, neon is 10. So then you can count up 2, 4, 6, 8, 10, 10, and then start at 3s and resume.
Okay.
All right, so those are what you're going to be doing for your assignment today. This is it. This is it. It's just tedious. All right, let's do sulfur. How many electrons does sulfur have?
A couple.
16. All right, so I start with my orbital. It's 1s. I fill it. There's my first 2 electrons. After 1s, it's always 2s. Then I fill it. Okay, after 2s, it's 2p. Okay, I'm at 10. After 2p is 3s. Here's 12. After 3s, it's 3p. 13, 14, 15, 16. So I fill an electron in each of those orbitals, and then I go back. Elvis Perkins. Okay, so there's my orbital notation. Okay, the electron configuration, I'm writing the numbers, the letters, and the exponents. So I have 1s, 2, 2s, 2, 2p, 6, whoops, 3s, 2, 3p, 4. All right, then the noble gas configuration. What's the noble gas before sulfur? Neon. So I put neon in brackets.
Because argon would be too far past. And then
Okay, so then after neon, I go down to the next row. It's 3s2. And then 3p4. All right, scandium, which is 21. 21. Okay, we do our orbital first. Got my 1s, my fillets. 2s, fillet. 2p. Okay, so now I'm at 10. After 2p, it's 3s. Okay, so now I'm at 12. After 3s, it's 3p. All right, I'm at 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm almost there. So after 3p, 4s. And we fill it. And then after 4s, it's 3d with 5 dashes. 1, 2, 3, 4, 5. So this is my D's have 5. F have, is it 7? Yeah, 7. Okay. So I'm at 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I just need 1. And there it is.
there's so many empty seats on that box.
Yeah. Okay, electron configuration, which is your exponents. 1s2. 2s2. 2p6. 3s2. 3p6. 4s2. 3d1.
SC is wrong.
Okay, so then the noble gas, what's the noble gas before scandium? Argon. So I put argon in brackets. And then we resume. So 4s2. And then 3d1. Do you have more? No. Okay, but in your notes, are there more? No, you don't have them? Okay, then I'm not going to worry about them. Okay, one thing I want to stress, the back of your chem book, you'll notice that they give you the abbreviated form. Do not trust it. It's in the wrong order.
Trust that shit.
Okay? Some of the abbreviated forms are right, but like for example, looking at scandium, they have this. Argon in brackets, 3d1, 4s2. So like when they printed it, they put the 3's before the 4's. That is incorrect because 4s has a lower energy than 3d. Okay? So if I'm just saying if you were to discover it on your own and be like, jackpot! Nah, it's not a jackpot. Tread carefully, all right? Okay, so I'll hand out the assignments.